You are looking at everything that has ever existed, and you can only see a tiny fraction of it. Right now, your eyes are taking in light. Photons bouncing off the words on your screen, hitting your retina, firing signals to your brain. That process feels instant. It feels like you are seeing the present moment. You are not. The light from your own hand, held at arm's length, took about 1 nanosecond to reach your eyes. The light from the moon took 1.3 seconds. The light from the sun left over 8 minutes ago. The nearest star sent its light 4 years before this moment arrived. You have never once in your life seen anything as it is. You have only ever seen things as they were. And the farther you look, the deeper into the past you are staring. The Andromeda Galaxy, the closest large galaxy to our own, is 2.5 million light-years away. That means the light hitting your telescope tonight left Andromeda when early humans were first walking upright in Africa. You are not looking at a galaxy. You are looking at a fossil of light from a time before your species had language. Now multiply that by 1,000. The James Webb Space Telescope, launched by NASA in December 2021, was designed to see farther than any instrument in human history. And it did. In its first deep-field image, released in July 2022, it captured light from galaxies that formed just 300 million years after the Big Bang. That light traveled for 13.5 billion years to reach a mirror floating in space 1.5 million kilometers from Earth. 13.5 billion years. The universe itself is only 13.8 billion years old. Webb was looking at galaxies that existed when the cosmos was barely a toddler. Stars being born from clouds of hydrogen so pure they had never been touched by heavy elements. No carbon, no oxygen, no iron, just raw hydrogen collapsing under its own gravity for the very first time. You were looking at the universe before it had ever made anything. But here is the part that will break your sense of scale. The observable universe, everything we can see, everything any telescope has ever captured or ever will capture, has a diameter of about 93 billion light-years. 93 billion. But the universe is 13.8 billion years old. How can we see 93 billion light-years across when light has only had 13.8 billion years to travel? Because the universe has been expanding the entire time. In 1929, an astronomer named Edwin Hubble made one of the most devastating discoveries in the history of science. He measured the distances and velocities of distant galaxies and found that nearly all of them were moving away from us. The farther away they were, the faster they were receding. Space itself was stretching. This was not galaxies flying through space like bullets from a gun. The space between galaxies was growing. New space being created between every point, every second, everywhere at once. The light from those earliest galaxies left 13.5 billion years ago. But while that light was traveling toward us, the space it was passing through kept expanding. The galaxy that emitted that light is now much, much farther away than 13.5 billion light-years. It has been carried outward by the expansion of space itself. So the observable universe is a sphere 93 billion light-years across, and you are at the center. Wait, are you at the center? No. Every point in the universe sees itself at the center of its own observable sphere. If you teleported to a galaxy 10 billion light-years away, you would see a different sphere, partially overlapping with ours, but with different galaxies at its edge. There is no center. The expansion is happening everywhere equally in every direction. This was confirmed in extraordinary detail by the Planck satellite, a European Space Agency mission that mapped the cosmic microwave background radiation between 2009 and 2013. The cosmic microwave background, or CMB, is the oldest light in the universe. It was released about 380,000 years after the Big Bang, when the cosmos cooled enough for atoms to form and light to travel freely for the first time. That light has been traveling ever since. It is the edge of what we can see, not because there is a wall there, but because before that moment the universe was so hot and dense that light could not move in a straight line. It was trapped in a fog of plasma. The CMB is the surface of that fog, now stretched by expansion into faint microwave radiation that fills the entire sky in every direction. In 1965, Arno Penzias and Robert Wilson at Bell Labs detected this radiation for the first time, almost by accident. They thought their antenna was broken. It was not broken. It was picking up the afterglow of creation itself. The CMB is the farthest back we can see with light. Beyond it, there is darkness, not because nothing exists there, but because nothing has had time to send us a signal. So what lies beyond the observable universe? The honest answer is, we do not know for certain, but every measurement we have suggests there is more, much more. Cosmological measurements from the Planck satellite and other missions suggest that the full universe could be at least 250 times larger than what we observe. Some models propose it could be infinite. If it is infinite, then beyond our 93 billion light-year bubble, there are galaxies we will never see, stars we will never know about, and possibly worlds with their own observers looking out at their own 93 billion light-year sphere and wondering what lies beyond theirs. This is not speculation. This is the direct implication of measured expansion rates and the geometry of space. And here is where it gets truly strange. About 68% of the universe is made of something called dark energy. We cannot see it, we cannot touch it, we do not know what it is. But we know it exists because it is accelerating the expansion of the universe. Galaxies are not just moving apart, they are moving apart faster and faster over time. In 1998, two independent teams, the Supernova Cosmology Project led by Saul Perlmutter and the High-Z Supernova Search Team led by Brian Schmidt and Adam Rees, studied distant supernovae and discovered that the expansion of the universe was not slowing down as everyone expected. It was speeding up. Something was pushing the universe apart. They called it dark energy. And it means that in the very far future, galaxies will be moving away from each other so fast that their light will never reach us. The observable universe will not expand. It will shrink. The sphere of everything we can ever see will get smaller, not larger. Distant galaxies will cross beyond our cosmic horizon and disappear forever. Future civilizations, if any exist, will look out at a sky that is almost completely dark. They will have no evidence that anything exists beyond their own galaxy. They will think the universe is empty. They will be wrong. They just will not be able to prove it. So how much of the universe can we actually see? About 4%. That is it, 4% of everything that exists is made of the ordinary matter you can see, touch, and measure. Atoms, stars, planets, your body, the screen you are watching this on, all of it, 4%. 27% is dark matter, an invisible substance that holds galaxies together through gravity but has never been directly detected. And 68% is dark energy, the force tearing everything apart. You live in a universe where 96% of what exists is completely invisible to you. You have built telescopes that can see galaxies 13.5 billion light-years away, and you still cannot see most of what is out there. The universe is not hiding from you. It is not playing a trick. The information simply does not reach you. It cannot. The speed of light, the fastest anything can travel, is too slow for the scale of what exists. By the time light from the edge reaches you, the edge has moved. You are always chasing a horizon that retreats the moment you approach it. This is the cosmic horizon problem, and it has no solution. It is not a flaw in our instruments. It is a fundamental limit built into the structure of reality. So the next time you look up at the night sky and feel small, know this. You are not just small. You are looking at the smallest possible version of the universe. A 4% sliver of an ocean so vast that its full extent may be literally infinite, and you will never, ever see it. The light you are catching tonight is a whisper from the past, telling you a story about a universe that is far larger, far stranger, and far more invisible than your eyes were built to understand. And the most humbling part? The universe does not need you to see it. It existed for 13.8 billion years without a single human eye. Your awareness of it is a recent accident on a small planet around an average star. You are the universe looking at itself, and even then it can only see 4%.